Hello dear students, myself Jambagi welcoming you all for the video number 2. In the previous clipping, we understood electricity, its branches, electric charge, types of electric charge and properties of electric charge respectively. I think I have missed few points as such importance of electricity as well as limited examples for charge is concerned. Firstly, here I am going to discuss about the importance. Secondly, few more examples on charge, and later we will move to the main concept of today's lecture. Now, let's focus on importance of electricity. Electricity is one of the blessings of science to the mankind. One cannot think without electricity at all. Now, we will pose few examples as such: lighting the rooms, working of fans, domestic appliances like ACs, electric stoves, geysers, all are with respect to electricity. In the factories, large machines are worked with the help of electricity. Electric trains, battery based vehicles are quick mean to travel. Electricity also provides the entertainment purpose as such TVs, radios, cinema and amusements. And similarly, modern equipments like computers, mobiles, robots are developed due to electricity. Electricity is also playing a vital role in the medical field too. As such, X-rays, MRIs, ECGs all are based due to electricity. Now let's move on to electric charge in day-to-day life. In the previous clipping, we also have some examples as such. Whenever you are rubbing the glass rods with silk, when you brought nearer to one another, they are going to repel, whereas when you driven with a plastic comb, when you are placing in front of pieces of paper, they are going to attract. These examples already known. Now let's move on with few more examples. We are going to see the spark in a dry weather when you are moving on a carpet. Okay, you can sense by touching a metal plate to that. Whenever you are taking nylon sweaters off or synthetic shirts off, sparks are going to seen. That is due to electric charge. Metallic bodies of cars, trucks almost get electrified due to friction between those materials or those outer bodies of the vehicles and air between them. Electric discharge is also one of the electric discharge during lightning is also one of the example for electric charge. I hope you are satisfied with these examples. Thank you. Again, I am welcoming you all for this video. Dear students, let us understand the concept of electric potential and potential difference. Before heading into that, I will just ask you a simple question. That is, how charges are going to flow? Is it seeming a bit interesting? Okay, so to understand that, let's bring a simple analogy in. That is the concepts of water containing two beakers connected one another. Okay, let's try to draw that. Now this is the first beaker which is connected to another beaker of same kind. So this is beaker number 1 and this is beaker number 2. Now let us add some amount of water in it. So whenever you are adding water to that, it will take all space it can. See, it is the water now. Closely looking to one another, they are leveled. Means water level appears to be same as the two beakers similar, which means whenever you are adding the water, the two ideal beakers connected by the pipe, so it's almost flattens, means it balances on the both sides. Now what does it mean? So let's go back to the previous year. Whenever you are stored water in a beaker or stored water in a tank or anywhere, what it possesses? It generally possesses the potential energy. So whenever you are adding the water to the two beakers, so it has its own potential. Now let us make the beaker 2 to rise upwards like this. So we are lifting the beaker number 2 to a certain height. Beaker number 2 to a certain height from the base. Now what do you find in the position of beaker number 1, and what will be the position in beaker 2? You definitely will observe 1 is going to rise, 2 is going to down. Means whenever you are lifting the beaker 2 up, you are getting the difference in the potentials of the water in the beakers. See, it is coming like this. It is moving downwards. Now beaker 1, the water in beaker 1 is rising. Means you are having the difference in the potential of the water in the two beakers. So one is having the potential and other one is having the potential difference. The analogy of two beakers containing water being preferred in understanding the potential as well as potential difference. For the flow of electric charge, let us bring a metallic wire like this. It has two ends A, B respectively. And in the second case, for that same wire AB, we are connecting a source of battery and a plug key to get the difference. In the first case of the wire AB, it has definitely potentials at point A and point B. Now it has its own potential. Now how do you move the electric charge in this wire to from A to B or B to A? Okay, for that you are giving a battery as a supply and a key. Once you switch on the battery, there is a formation of higher potential at one of the ends and other one will be the lower potential. So as if it is in the rise of the down of the water level in beaker 2. So similar thing is happen, therefore we are getting the potential difference. Note that in both of the cases, the analogy of water containing beaker as well as the wire having the potential and potential differences, work has to be done. Therefore, we are defining electric potential in accordance with that. Now, let's define electric potential. The work done in moving unit positive charge or any charge which is unit positive charge here from one point to another, from one point to another is known as electric potential. Okay, it is denoted by the symbol. It is denoted by the symbol capital V, and it is a scalar quantity. It is a scalar quantity. The electric potential is measured in volt. It is measured in volt. SI unit will be volt. This is named after Alessandro Volta, the Italian physicist. It is either written in small letter VOLT or capital V according to the rules of SI unit. Now let us move to the next part, that is electric potential difference. Now let us define electric potential difference. It is also called as voltage. It is also called as voltage. Electric potential difference is defined as the difference between any 2 points of a conductor, 2 points in a conductor of potentials is known as potential difference or voltage. It is also denoted by the symbol. It is also denoted by the symbol by V, or sometimes it is written as PD as a shortened form of potential difference. And remember, that is also a scalar one because it is a difference between the potential, therefore same scalar quantity as well as SI unit remains same. Mathematically, potential difference is given by work done divided by charge. Work done divided by the charge. Therefore, potential difference is equal to capital W divided by charge Q. This is the simple mathematical formula. As I already said that since it is the difference in the electric potentials, therefore SI unit, that is volt, remains same. Let us define 1 volt of potential difference. Let us study 1 volt of potential difference. What does it mean? So the potential difference between the two charges is said to be 1 volt if 1 joule of work done 1 joule of work done in moving 1 coulomb of charge. 1 coulomb of charge. That is known as 1 volt of potential difference, which means the potential difference between any two charges is said to be 1 volt if 1 coulomb of if 1 joule of work done in moving the 1 coulomb of charge. That's why it is written as 1 volt is equal to 1 joule divided by 1 coulomb. Therefore, 1 volt is always equal to 1 joule per coulomb, or simply joule per coulomb is considered to be as 1 volt. Now, voltmeter is the device we are using to measure the potential difference between the 2 points in the wire. Voltmeter is the device. Remember, voltmeter is always connected in parallel to the 2 points, like this. As I am saying that it is connected parallel. How? Let us bring a small circuit in. If it is a wire having the points A and B respectively, you are connecting the voltmeter like this, and A to the positive end of the voltmeter and B to the negative end of the voltmeter. Remember, vice versa can be done. Now let's move on to electric current. When two different potentials are connected by a metal wire, then the electric charges are going to flow from higher potential to the lower potential. Higher potential means the region of higher concentration, and lower potential means of lower concentration. So charges are ready to flow from higher potential to lower potential. Charges are going to flow from higher potential to lower potential. Now, with this understanding, let's define electric current. The flow of electric charge when the potential difference between two ends of a conductor maintained is known as electric current. Is known as electric current. So the flow of charge when the potential difference between the two ends of the conductor maintained, or in other words, simply the flow of charge or the flow of electrons are also considered as electric current. It is denoted by the symbol I. It is denoted by symbol I. Now, electric current mathematically written as electric current I is equal to the flow of charge with respect to time. Therefore, I is equal to Q divided by T. Now, it is also a scalar quantity. It is also a scalar quantity. SI unit of electric current is given as ampere. It is written either small letter ampere. It is also the name of the scientist. Andre Marie Ampere. Let's define 1 ampere of electric current. Let's define 1 ampere of electric current, or simply you call it as current. When 1 coulomb of charge, flows through a conductor, in 1 second of time. The current is said to be current is said to be 1 ampere. 1 ampere of electric current means when 1 coulomb of charge flowing through the conductor in 1 second of time. Therefore, it is given by 1 ampere is equal to 1 coulomb divided by 1 second. Therefore, 1 coulomb per second. So, ampere is equal to 1 ampere is equal to 1 coulomb per second. Now, electric current is measured by the device called ammeter. It is measured by the device called ammeter, and it is always connected across the wire. Okay, so whenever you are trying to connect the ammeter, you must follow, it should pass the wire like this. If you are taking the points as X and Y, so ammeter is always connected across the wire. And note also that the current for the shorter scale as milliampere and microamperes respectively. For shorter currents, we are measuring MA and mu A, milliampere and microamperes respectively. I hope you enjoyed the video. We will see you in the next clipping. Thank you for watching.